So let's get started. First thing you want to do is start off with our calculators, and we're going to switch back to degrees a little bit today, and then we're going to tie it all back into the unit circle later on. But we're going to look at different ways of writing some angles with more specificity. So you guys know degrees, right? But there's also a subunit of degrees, kind of like if you know there's the idea of there's days of the week. Well, with those days, there's also subparts of the days called hours. And of those, there's subparts called minutes, and of those, subparts called seconds. And there's actually, the subparts of degrees are actually minutes and seconds, right? So it's kind of a weird thing because you think minutes and seconds, well, that's strictly about time, what time of day it is, but it's also a way to measure degrees with more specificity, right? Just way more specific, yeah. And one way of looking at it is that you might have seen signs like this, right? Where it says 42 degrees and has 54 and 17, has all these three numbers, right? That's what this is: degrees, minutes, and seconds. So the minutes we use this little apostrophe, and the seconds we use the double apostrophe. But this is like longitude and latitude, right? That's why it says north 42 degrees, and this is west, so you're in the north part of the hemisphere, northern hemisphere of the world and the western hemisphere of the world, and these are the exact locations, right? So that's what we're going to be learning today, is how to get these values over here. You know about degrees, but how do you get these other minutes and seconds? How do you convert back and forth? It's just a very formulaic thing. It's kind of like, if I gave you 15 minutes, how would you convert that to decimal? Right, well, 15 minutes, 15 out of 60 minutes, that's 0.25. So 4 hours and 15 minutes would be 4.25 hours. So it's how do you convert the 15 minutes into the decimal, or the other way around. If you have the decimal, how do you convert that to the minutes? So if I scroll down here a little bit more, there's probably one with a decimal at some point. All these different signs. Yeah, here's one that's all decimal. So you can represent your longitude, latitude in different ways with this degrees, minutes, seconds, or just have big long decimals. So your task today is just to know how to take the decimal, convert to the minutes, seconds, or minutes, seconds, convert back to the decimal. Okay, so just two ways of representing the same thing. And if you go on Google Maps somewhere, you can click on anywhere, and it always gives you the longitude, latitude in decimal form, right? So any location anywhere on the surface of the Earth has some sort of numbers assigned to it. Okay, so of course that all ties into trig and everything we're doing, right? Just a cool little thing. So that's what we're going to look at. But first you got to use your calculator, right? And of course you need to have a handheld calculator, not a phone app, while you're doing this. So just to make sure, we're switching back to degree mode. So if you've been using your phone for a while, your calculator for a while, it's probably already in radian mode, right? So you want to go into mode, and you might see this somewhere. It says degree, radian, and then this thing's called gradient. It's a little slightly different than radians. And this is one reason why you want to have a calculator of your own, so you know where all these settings buttons are, you know how to find them, switch back and forth. If you just grab a random calculator right for a quiz of something you've never used before, it might be in the wrong mode, and you're like trying to spend quiz and test time how to switch the right mode and whatnot. So just for peace of mind, have your own, name it. And then let's go ahead and type in sine, just to make sure it's working fine. Sine 45. Now, in some calculators like this one, it gives you the full solution, right? It actually says it's equal to root 2 over 2. Most of them do not, which is why I recommended this one from day 1 and day 2, first day, second day of school, so you could actually see that. And then you can hit the approximate button, and it'll give you the decimal, right? 0.707. Of course, if you're in radian mode, and instead of 45, you would have typed in pi over 4, and that would have given you the same thing. So this is like a Fahrenheit, Celsius, degrees, and radians. They do the same thing. The numbers are different, but like 21 degrees is the same as 89 degrees Fahrenheit. it feels exactly the same outside. That warmth feels exactly the same, even though there's two different numbers representing that warmth. Okay, so that's how you want to look at this. Pi divided by 4, that's 3.14 divided by 4, right? And 45 degrees are very different numbers, but yet they give you the same answer, depending on what units we're working in. Same thing here. Cosine of 180, you don't need a calculator for that, but you can try it out. You should already be able to anticipate the answer. This is asking what's the x coordinate at 180 degrees on a unit circle. Alright, so of course that comes out to -1. And if you're in radians, that would have been cosine of pi. And that would give you the same answer. So that's degrees, that's radians. Just showing the parallels between all this stuff. And 225. Tangent. Press the tangent button, 225 degrees. Of course, that comes out to +1, right? It's on a unit circle. It comes out to what? 5 pi over 4. Same as tangent of 5 pi over 4 in the third quadrant. So that line has a positive slope, +1 slope. So it's important on here because let's say you didn't know if you're in the wrong units, right? So you know cosine of 180 is -1. But let's say I thought I was in radian mode. Cosine of pi is right here. I want to be able to look at that and say, wait a minute, cosine of pi, that should equal 1. Oh, I'm in the wrong mode. So as soon as you see a wrong answer, you know something's off and you don't just keep on doing like your whole quiz or homework or test. Right? So that's part of using a calculator is realizing, well, when an answer doesn't make sense, you got to check your settings. You don't just, well, that's just what the calculator said, so I just did it, and then come up later, oh, I did my whole quiz. Can I redo it because I didn't know? That's part of the test. That's part of the class is knowing when an answer doesn't make sense. You don't just say, well, calculator is the smart one between the two of us. Between the human and the calculator, the calculator wins, and that's the wrong answer. So when you detect something wrong or you should notice something is off, and then you should fix that, and that way you know you're not making a mistake every single step, right? Because some people rely on the calculator too much as of like, well, since I have a calculator, I really don't have to know it that well because the calculator doesn't work. And it's only as smart as the user, right? Because my professor in college used to say, calculator is really dumb because it does exactly what you tell it to do. So if you put it in a mode or not put it in the right mode and then put an answer, it gives you that. It doesn't fix anything for you, right? So you have to know better. All right, and as I mentioned before, we have our degrees. Now, if you want to think about this as degrees as hours, and that way it's like hours, minutes, seconds, it's somewhat comparable. It's not quite the same because we have 24 hours in a day, whereas degrees goes to 360. But it's all part of the same ancient Babylonian base 60 number system, right? 24 and 360, these are all numbers that divide in there. So it's somewhat useful, and it all comes from the same, same ancient number system from a long time ago. So we got two parts here. Is how do you take something that's in that degrees and minutes notation, right? This would be like 23 hours, and think about 23 hours and 14 minutes. And what would that be as a decimal? So really the question is like 14 minutes of 60, what decimal is that? That's really what the question is. So you want to think about this. Let me make this bigger. While you're doing this, you're really just converting this part, right? You're trying to find out what that is. So this is going to be cosine of 23, right? But 14, what is 14 minutes out of 60, right? And that will give us the decimal part, right? So after this, I'll be able to say, okay, this is cosine 23, right? And then head over to the calculator and find out, well, what is 14 divided by 60? All right? So 14 divided by 60, as you can see, is 0.233, like that. So that's now the decimal part. That's the 0.2333. So the whole number stays the same, and it's this minutes that I'm converting. It's out of, since there's 60 minutes in a degree, I just do 14 out of 60. And then I can take the calculator, right, and actually find out what the cosine of this entire decimal. Now, there's some shortcuts of a way of doing this. So you can see I already have 0.2333 on my calculator. So what I'm going to do is just say plus 23. All right, I can just go plus 23. And then some calculators, you can just hit cosine, and then it'll give you the cosine. Other calculators, you'd have to retype it. So it just depends on your calculator and how it works. But you can hit cosine. I can go up here and hit the cursor, right, and just hit enter on it, and it puts it in right for me. Or you can just type it all out. So part of it is just getting comfortable with it and seeing what you get. This comes out to 0.9182. And since this is rounded, I should be careful. Since this is a rounded answer, I'm going to use approximately, not an equal sign, but approximately. Anytime you see something like this in the directions where it says round to ... that's a cue that this is going to happen. So when you see round to, usually means you're going to be rounding your answer, right? So have an approximate sign, not an equal sign. So 91 minus 82. Now if you put another 3 here or one less 3, this might be slightly different. So pay attention to the directions just to make sure you're consistent. All right, now you guys try for B. Very similar. Oh, not sorry, B. For 3. So you got sine of 81 degrees, 37 minutes. Make sure you pronounce the degree you know very well. That symbol, you pronounce minutes. Just spelled the same as like time. Okay. See what decimal you get. Okay, so you should come out with something like that. All right. Let's take a look at B. Go in the other direction. Let's take a decimal and write it in the degree, minute, second. Sometimes this is abbreviated, by the way. So this, when you're talking about this format, you can just say you're converting it to DMS. So on calculators, you often see a DMS button or a DMS window. Okay. So I think on mine, if I go to math right here on the math button, and I scroll over, you can see there's a DMS menu, and then you can see the degrees, the minutes, the seconds, right? And there's a few other things here as well. So remember, this is not the number we're converting, but we're converting the degrees, right? So we actually need to get the degrees first. So if sine of A equals 0.777, that means A is going to equal the arc sine. Right? So whenever you want your answer, some people kind of try to remember when do you use arc sine? It's when your answer is an angle. If you want to get the final answer to be an angle, at some point you have to use an arc button. You're going from a decimal, right? You want to end up with a angle, use that button. So on this one, I just have to press the sine button twice, right? And that gives me arc sine. Some other calculators, you have to hit the second button and press the sine button, so it's different for every single one. So I just do 4 sevens. All right, so I get 51, 0, 5, 0. So I got 4, 6, so that 6 is going to round the 4 up to a 5. Round to nearest 4 decimals. Okay. So now the question is, now we got to do this process in reverse, right? So I already know that the 51, right, is going to be 51 degrees. The question is, how do we get this minutes? How do we go backwards? Well, to go from here, we did 14 divided by 60 to get the decimal, so reverse it, right? We're going to take the decimal and multiply by 60. So I'm going to take this part, right, which is 0.0505, and I'm going to multiply that by 60, right? And that will give me the actual amount. So I want to have just the decimal part. So what I'm doing on my calculator is I'm going to subtract the red part, take off the 51, so minus 51. All right, there's just the decimal I want to work with. Then I can multiply that by 60. And it comes out to 3 minutes. Okay. Now, much like a clock, much like time, minutes works exactly the same. So one little formatting issue. So if I said if it's 2 hours, 4 minutes, how do you actually say that when you say what time it is? 2 hours and 4 minutes. How do you say that on the clock? Or how do you write it on the clock? 2:04, right? You don't just say 2:04. You don't just say, well, it's 2:04, right? You always put that 0 in front. So we do the same thing here. The minutes will always be 2 digits. Okay, from 0 to 59. So small formatting thing. The minutes has to be 2 digits. All right. So give tangent 1.234 a go. And as we're doing this, think about this before you go calculator on it. Will the answer be bigger than 45 or less than 45? Think about that. So what's the tangent of 45? 1. So will this angle be bigger or smaller than 45? It'll be bigger, right? So I want these numbers, when you see tangent of this, sine of that, actually to have some sort of meaning and not just random. Let's put in calculator, see what the answer is. You should already be expecting, like, well, tangent of 1 is 45, pi over 4 is 45. So tangent of 0.234 more than that. That's just going to be just a slightly bigger angle, right? So you can already anticipate what the answer should look like. That'll help out a whole lot on standardized tests, multiple choice tests, right? If you can eliminate a bunch of answers that just are impossible because you know approximately what the answer should be. So the ones that practice that get better at it will end up doing a lot better than the ones that just rely on the calculator only. As promised, that 0.234 more, it came out to 50 degrees. So if it's just 1 by itself, it would have been 45. And this little decimal more just increased it by like 50 or 5, 6 degrees. Right, made it a little bit bigger. 6. Right. So of course, this is the degree. 50 degrees. And this part is the minutes. And this will come out to, what, probably like 59-ish is my guess. 58, 59 if you round it. Because this is saying, this is like almost another degree. This is saying like 98, you got 98% through the next, to the next degree. So you're like very, very close to getting to the next degree. Alright, so that's what we should get there. Now there's a way we can keep on going and get more specific and actually look at the seconds as well. We're going to stick strictly to degrees and minutes today. We're not going to get into the seconds. Although we could and just do one more conversion. Okay. So that's just the simple conversion of decimal to DMS, degrees, minutes, seconds, and degrees, minutes, seconds to decimal. They say the same thing, just in a different way. But now you're going to use it to actually solve some right triangles, so doing some old-fashioned geometry, trigonometry on here, and practicing and including all this good stuff in here. So let's look at this. So you can see the angle is given in the degrees minutes format. So we're going to stay in that format, okay, throughout the problem as we can, as much as we can. So start, as always, draw a picture. Pictures are useful. You can mark what's given. Well, I'll keep that in black. So we got 31.27. Oh, no, sorry. 31 degrees, 27 minutes. Okay, of course, this is our 90 degree. So don't worry about that. And we're given B. Let's see, call this A. Call that makes this B. This is C. So we got 9.3. And we just need to find all the missing information. So we need to find 3 things. We're looking for the angle, B. And this needs to be in degrees minutes, right? I'm going to leave this in degrees minutes. And then we need to find side A and hypotenuse C. So 3 different problems, 3 different answers. So the first one is, remember that A and B, since this is a triangle, this is 90 degrees, A and B add up to 90, right? Angle A plus angle B equals 90. So we have angle A already, which is 31 degrees, 27 minutes. And we just need to subtract that on both sides. Yeah, the same thing you've been doing probably since elementary school. Oops, I made a mistake. Change that to degrees, minutes. There we go. So, of course, that cancels out. Now we have angle B is going to equal to 90 minus this. Now, much like, I don't know, borrowing, we can't really just subtract these 2 numbers easily. So, you know, kind of like if I gave you, I don't know, 102 minus 27, you can't say, well, okay, it's 2 minus 7, oh, I get negative 5. 0 minus 2, I get, you know, that doesn't work. We had to go through this whole thing of borrowing and saying, well, if this doesn't work, I got to go here. If this doesn't work, okay, that's a 9, and you have to go through this whole process on how to borrow. Same idea here, that Well, I need something to subtract from, right? So what I'm going to do is I'm going to change 90 into 89 degrees and 60 minutes, which of course equals 90 degrees. It's kind of like if I said I had 24 hours. I'm going to say I'm going to write 24 hours as 23 hours and 60 minutes, because 23 hours and 60 minutes is still 24 hours. But when it's written this way, now I can actually do the subtraction, right? Now I can do 60 minus 27 and actually get a number, which is 33. 33 minutes. 89 degrees minus 31 degrees is now 58 degrees. So you'll see this 89, this conversion from 90 degrees to 89 degrees in 60 minutes regularly, you know, because to subtract anything you need to have it written that way. So we have just determined what this angle is. So this will give me the answer as well, and then I can also convert this. Double check everything. So again, having the right calculator, having the right tool definitely helps on here. I think on this one, it's if you're on the Casio, you can just type in that, or what, 58. Oh, I think I pressed it wrong, but there's a button here. Yeah, it's easier to convert on here. You just have to press the button that's right on top. You can see the degrees, minutes, and seconds right there. So that has a button, an easier accessible button right on the main menu. Whereas here, I had to click math, I had to scroll over every single time to get to my symbols here. So on this sense, you know, the Casio is a little bit easier to use. So it just depends on the particular problem. All right. So that's one part. We still need to get two sides. Now the missing sides are just trigonometry. There's no pre-calc here. There's no, you know, we just have to go to old-fashioned, and you have multiple correct ways of doing it. So you can pick your way. I'm going to use some trig. You can also use Pythagorean theorem after you get one of them. But let's say I want to get A, right? I want to get this. So I can use the idea that I have A and I have 9.3. So I'm trying to find the rise using the run. So hopefully if you hear rise and run, you know a trig function to use right away. That would be tangent. So if I do the tangent of 31 degrees, 27 minutes, that's going to equal that rise divided by the run. Right? This is basically the same as saying I know the slope and I know the run. I'm trying to find the rise. Because remember, for you guys did up this over this, up this over this for slope for so long. Well, the angle is basically the same thing. So I have to go through here and figure out, well, what this is right here as a decimal to use the calculator. So I'm going to have to repeat the process from above. If it's given to you in minutes, I need to convert it to decimal first. Then I can put that in the calculator and get the right value and then solve the equation. So I have to do this part down here. Okay? So this is going to be equal to tangent 31 plus 27 over 60 equals my rise divided by my run. Okay. So I'll do 27 divided by 60. So 27 divided by 60 is 0.45. Is that what it comes out to be? Yeah, 0.45. That means it's 45% of 1 hour. 27 minutes is 45% of an hour. You know, that sounds right, because 30 minutes would be half an hour. So 3 minutes short of that is 45% of an hour. So we can, again, anticipate some of these and estimate what the decimals should be. So now I got a decimal, and I can just solve by multiplying both sides by 9.3, right? This is just a review, you know, from geometry problem right now. 9.3 times tangent of 31.45. We get about 5.7 I'll round to. Since I rounded, it's approximately equal to. Okay, so there's the second answer. It's about 5.7. Now you didn't really have a choice on to use tangent or something else because you only had 9.3 and we're trying to find the rise here, so you kind of had to use that. However, I could have found C first and I would have used adjacent over hypotenuse. I would have used cosine if I found C first. So the order of which you would solve these, you know, I just kind of went to A first. If you went to C, you might have, your math would look very different, right? It could still be correct. Just know that when you're checking each other's homework or working on it together in any way, if you're like, no, I use tangent. No, you got to use cosine. Well, whoa, step back. What variable are you solving for? You can both be correct. So multiple correct ways. And now at this point, you have a leg, you have two legs of a right triangle. You could use Pythagorean theorem, right, and say, well, c squared is going to equal 9.3 squared plus 5.7 squared. And solve that. Now you could also say, well, I can use like I just mentioned, use 9.3 and C. That would be cosine. So someone else could say, well, I could do cosine of 31 degrees, 27 minutes, and that will be equal to 9.3 over my hypotenuse, C. And you can solve that, and that will give you the same approximate decimal. It's just, you know, your preference, whatever you like. Yep. Which one? Which that? The cosine one? Slightly, just because we know 5.7 is a rounded answer. It's really 5.687, you know. So these decimals will be slightly different, with the bottom one being more correct. But with the accuracy that we're going for, I think the tenths place will come out to be the same anyway. But it's up to you. Some people say, like, well, do I have to convert this 31.27? I got to get a decimal. I got to do all this stuff. Pythagorean theorem's a little bit faster. You know, I don't have to do any of that stuff. But, as you probably already thought about it, it's over here. We already figured out that 31.27 is 31.45. So I can instantly solve this, right? I can switch these two. Remember, if I try to solve for the bottom, those switch. So this is going to be equal to 9.3 divided by cosine of 31.45. Put that in the calculator. Over here, I just, really need to take the square root, right? And C will be approximately that. So I can do both of those right here and say we got 9.3 all over cosine of 31.45. And I get about 10.9 approximately. We're using that approximate sign an awful lot when you're dealing with trig. But I could also use the up here and just punch this in. So I could do square root of 9.3 squared plus 5.7 squared. So you can see just to punch that in is a little bit faster using Pythagorean theorem. And it comes out to 10.9. So either way, all right, I want to emphasize right now, though, this isn't, right here, the blues is an OR. This isn't, you have to do it both ways, but just showing you get the same exact thing no matter how you go about it. Okay. So this comes out to 10.9. All right. So you got a little bit of time. I suggest right now let's get started on that one. Just practice, get it going started. It doesn't give you an angle to start off with, so you have to do that on your own. But, yeah, good trig review.